Hello everyone. So as promised, I thought I'd talk through this last example in section 5.2 such that you guys can go ahead and knock this out on your homework. So this is an example where we're trying to find the area of a side-side-side triangle. It says using Heron's formula, but you don't actually need Heron's formula, so I'm not going to teach it to you. And just so that you kind of know where we are, just to be checked, we're on slide 111 of 120 in your notes. And we're going to go ahead and talk through this example. We're looking to find the area of triangle ABC that has side A equal to 11 meters, side B equal to 17 meters, and side C equal to 20 meters. And so first things first is to draw a triangle. So we're going to go ahead and do that, and we're going to label our sides correctly. And of course, once we label our sides, then that determines which angles go where. So again, remember that every angle, which is denoted by a capital letter, goes across from the side that goes with its lowercase letter. So let's fill in where the angles are. And where we want to start here is that we actually need at least one angle in order to calculate, to use our area formula. So I'll go ahead and write that out now. So just as a quick note, again, we want to use our area formula, but we need to have the value of at least one of our angles. And right now, as our problem is written, we don't have one. Okay, so we want to use the area function, but we need an angle to do so. And how do we find an angle in a formula in a triangle where we have three sides? Well, it works very, very similar to how what we did when we were solving triangles, when we were giving side triangles. And that is that where you want to start is you want to start by using the law of cosines. So we want to go ahead and find angle C. Why C? Because C is our angle that is across from our largest side. So we're going to use the law of cosines to try to find angle C. And so that means that the formula that we need to use is the corresponding formula. So it's C squared looks like A squared plus B squared minus 2AB times the cosine of C. And with that, we should be able to fill in all of this information except for the angle, because that's what we're looking for. So C squared is 20, A is 11, B is 17, and so we should be able to substitute in all of those values into the law of cosines, of course leaving angle C there. Now, exactly in the same manner in which you would have solved for C in section 5.1, we're going to do that. So I'm actually not going to show all of the work, so I expect you guys to go ahead and fill in the gaps here. But you end up with the expression that's written here that tells us that angle C has to be the inverse cosine, the arc cosine of the expression there. And if you correctly put this into your calculator, then you should end up that angle C is 88.47 degrees. Okay, so now we have an angle, which theoretically makes our problem a whole lot easier. And now we can use the area formula that we have for our triangles. So if you recall, the area formula for a triangle is 1/2 times A times B times the sine of angle C. And now that we have angle C, we can just substitute right in. So that means that this is equal to 1/2. A is 11, B is 17, and now we know that the angle C is 88.47 degrees. Substituting in all of that, putting it into your calculator carefully, be sure you should get that the area of this triangle is 93.46 meters squared. Alrighty, that is it. So hopefully you understand this. If you have any questions, please let me know. Please email me, contact me, ask me questions in class. Other than that, that should be all that you need in order to finish your homework. Take care. Thank you. Bye.